Bridges 6.4, complex fractions. Some people say that all fractions are complex, but when I say complex fractions, that basically means it's a fraction with fractions inside it. So fractions inside of fractions. Whoa! They say that 5/4 of people have trouble with fractions. Anyway. So something like this would be considered a complex fraction. So if you've got like x plus 2 over 3 over x minus 2 over x. So that's considered to be a complex fraction. But what we really need to understand is that this complex fraction is basically just a division problem. And this thing right here is like the division symbol. And so this means the exact same thing as x plus 2 over 3 divided by x minus 2 over x. And if you recall from 6.2, we know that that is equal to x plus 2 over 3. We keep it, we change it, and flip it, so that changes to times. This one flips over. And lo and behold, when we multiply this out, there's nothing to cancel out. And so we have x times x plus 2 over 3 times x minus 2. And that would be your answer because nothing else simplifies. So really, this is just like division, it just looks big and scary. All right. So if we look at another one, let's say I've got 4y cubed over 5x quantity squared over 2y quantity squared over 10x cubed. So if we rewrite this as a division problem, this would be 4y cubed over, now when I square out this denominator, since it's all multiplication, I can square the 5 and square the x. So that'd be 25x squared divided by 2 squared and y squared would make 4y squared over 10x cubed. Now once again, we change from division to multiplication. So this would be equal to 4y cubed over 25x squared times 10x cubed over 4y squared. Now at this point, you could multiply this out and then simplify it, or you can just simplify it as is. If I take this x squared, that'll kill off 2 of those, and that'll just be x. If I take this y squared, that'll kill off 2 of those, and that'll be y. 4 and 4 cancel out, so that's just a 1, and that's a 1. And then notice that 10 and 25 have a common factor of 5. 5 goes into 10 twice, 5 goes into 25 5 times. And then I just multiply what's left. 1 times y times 2 times x would be 2xy over 5 times 1 is just 5. All right, let's continue. So if I have like x plus 1 over x plus 2 over x plus 1 over x plus 5, that's the same thing as x plus 1 over x plus 2 divided by x plus 1 over x plus 5, which is the same thing as x plus 1 over x plus 2 times x plus 5 over x plus 1. Notice that all these are factored. I can cancel out the factors that match. And I'll end up with x plus 5 over x plus 2. Remember that this becomes a 1, that becomes a 1. And 1 times whatever, those ones ultimately don't matter because it's multiplication. And so, therefore, this would be your answer right here. Okay. Let's see what else we have here. Here's one that's a little bit more complicated. X squared plus 4x plus 3 over x minus 2 over 2x plus 6. Well, what we need to understand is that this would be equal to x squared plus 4x plus 3 over x minus 2 divided by 2x plus 6 over 1. So I can make that into a fraction. Then I'm going to keep change and flip x squared plus 4x plus 3 over x minus 2 times 1 over 2x plus 6. I'll need to factor this. And of course, you can factor as you're flipping or as you're rewriting. It really doesn't matter. Or you can write it out in separate steps like I did. What multiplies to give you 3 but adds to give you 4? X plus 3, x plus 1. Notice there's a common factor here. The x plus 3's cancel. So I'll end up with x plus 1 over 2 times x minus 2, or x minus 2 times 2. It really doesn't matter. Notice that everything's factored and nothing else cancels, so this is my answer right here. All right, now let's try this. X over 3 plus 2/3 over 1 minus 2 over x. Now, you've got a couple of different ways that you can approach this, but one way can be getting a common denominator and combining these separate fractions. So if we take a look at this numerator here, notice that we've got 3 in the denominator in both spots. So what I can do is I can put that together with a common denominator, and that would look like x plus 2 over 3. Now, if I look at this denominator here, I've got a 2 over x and I got a 1. Well, that 1 is like 1 over 1. Whoops. Get rid of that. 1 over 1. So, if I get a common denominator here, I would have to multiply by x up here by x down here. So then I'd have x over x minus 2 over x, which would look like this. X over x minus 2 over x, which would then be x minus 2 over x. And at this point, you probably recognize this as the same problem as the very first one we did in the section. So this is the same thing as x plus 2 over 3 divided by x minus 2 over x, which is the same thing as x plus 2 over 3 times x over x minus 2, which would of course be x times x plus 2 over 3 times x minus 2. And none of that cancels, so that's your answer right there. Whoops, I forgot a set of parentheses. Whoa. I forgot a set of parentheses there. Let me fix that. Oh yeah, there it is. That'll work. Anyway. So, page 402. 6 through 16 even, and 26 through 32 even. Wow, that was under 10 minutes. Getting better at these.